Okay, welcome to your next lesson on the different parts of the toe ball assembly. The lesson today is going to deal with this spring washer, which is made from sprung steel. The spring washer is a little bit different from a normal washer in that it's not dead flat. It's actually a helical shape, and the idea is being made from sprung steel, it will always provide a spring-like effect so that our nut does not come loose. So there's no dimensions or anything given to us on this drawing about the spring washer, so we need to go to a table of conventions to work out some appropriate sizes. If you go to your classwork PowerPoint and if you go towards the end of the document, you'll find a table on about page or slide 48, and it's called Conventional Representation. And this table here gives us lots of information about different threads and all the different sizes and so on. So we know we're dealing with an M16 by 2 thread on the bolt and so on, and if we can look here we can see that there's a whole lot of different letters across the top of the table here that relate to different letters and sizes on bolts and nuts and so on. So we can take some information perhaps from the information given to us here about the bright washer, and we could apply that to our spring washer, even though they're not exactly the same. So we could look at our internal diameter, our external diameter, and perhaps our thickness. So we've got M, N and P. So if we look here we can see that's these 3 columns. So we'll go across. M16 has a washer with 32 being the outside diameter, 17 the inside diameter, and 2 being the thickness. So 32, 17 and 2. So remember that, and then we'll go across to Creo, and we'll start ourselves obviously a new part. I might call this one, I should call it spring washer. And obviously turn our planes on, and straight away we're going to jump into the Helical Sweep tool again. So go to Helical Sweep, and we'll go to References and Define, select a vertical work plane and click Sketch. Go to the Centerline tool, place the center line in, and then put a line in to represent the diameter of the helical spring and also its height, if you like, or its length. So we could use the line tool and select. So the outside diameter from one side to the other was 32, and its length, total length for this helix, needs to we need to work out that if it starts here and it turns around and goes around itself once, then it has a pitch of 2. So this line here should be 2. Okay, so we now have a line to represent diameter and pitch, or length if you like. Okay to that one. And now we use our sketch of the section tool up here, and then we can put ourselves in a rectangle to represent from our center line out to our pitch here, or out to the end of the line. Put in a rectangle to represent its profile. So I'll use my tools here, change it to 2 millimeters in thickness, and I'll use my dimension tool to work out the distance from the center to there, and that was a distance of 13, was it? I can't quite remember. 16, 17 to the center, so 32, which was 16, and what's it, 8.5 to the center. Okay, so 8.5. Okay, so we click OK, and we can see here now that's something a little bit strange. Oh, we need to put in the pitch. So pitch of 2 and enter. And we can now see that we've got a start point. It's revolving around once, because we've given it a pitch of 2 and also a length of 2 back in the references. Now, spring washers aren't exactly like what you see here. Spring washers actually do stop a little bit short of 1 full revolution. The idea there being that when the spring is under tension, you don't want these two surfaces come into contact with each other and it not working properly. So what we'll do there is we'll just reduce the length of the, not the pitch, but the length of the whole helix. So go back to your references and we'll edit that internal profile section. And instead of this being 2, we might just reduce that down to say 1.95. Okay. And then you can see it's, because it's now been reduced, it's not going to do the full sweep all the way around. Okay. Okay to that. And there you have your sprung steel or spring steel spring washer.